In this short video, we'll be discussing how to compute the determinant of a 2 by 2 matrix. So let's consider the following matrix. Say our matrix friend A is equal to the matrix 1, 7, 3, and 4. And the notation for a determinant actually looks very much like absolute values, although we'll see this is not an absolute values in the sense that we know by any means. And the way to compute a determinant of a 2 by 2 matrix is we first consider the diagonal entries along what we call the main diagonal of the matrix, and we take their product. So in this case, 1 and 4. And in this case of a 2 by 2 matrix, we then subtract off the product of the reverse diagonal, which in this case are the items 7 and 3. And I just want to draw our attention to that this is really specific for a 2 by 2 matrix. We have the product along the main diagonal, and then we also have the product of the reverse diagonal. This formula is going to change significantly once we start considering matrices of higher order, so 3 by 3, 4 by 4, and so on. But for us in this two-dimensional case, or the 2 by 2 case, we can take these two products, take their difference. So in this case, we have the product of 1 and 4 is 4, and we subtract off the product of 7 and 3, which is 21. So at the end of the day, this matrix determinant is actually equal to negative 17. So what I want us to then just notice are two things. The first thing is that the determinant can be negative. The second thing I want to draw our attention to is actually that the determinant is in fact a scalar. And if you're unfamiliar with the term of a scalar, what we really mean by this is that it's just some number. And like we saw in this case, it can be positive or negative. It could even be equal to 0. But the determinant is a scalar value or just some number. And one of the things I want us to notice from this 2 by 2 case is we're going to need this 2 by 2 case to compute the determinant of a 3 by 3 case. And we'll see in the next video that for a 3 by 3 matrix, we're going to see a sort of recursive relationship on how to find determinants of higher order matrices. So a 3 by 3 matrix, we're essentially going to break the determinant problem into one involving sequential 2 by 2 submatrices. Check out the next video.